So, hello, good morning. Welcome to the lecture on Numpy, Pandas, Matplotlib, and seaborn. So, earlier in the previous video, we discussed about Python. What is Python? Where it is used? See, I didn't discuss syntax in detail. I already attached the document or the file which I shared in the previous video in the description itself. And the same I'm going to do in this lecture as well. I'm not going to cover the whole Numpy, Pandas, Matplotlib, and seaborn, but these are the four most essential libraries that you definitely should know before beginning your machine learning or data science journey. Okay, so it's like, you can, if you just say, um what can I just say? I can just say that, okay, if I just say this is the Python. Okay, this is a Python. Okay, uh, this comes above all. Python is above all. Python is must. Python is necessary. You cannot skip that. Like, in the same way, we have NumPy, Pandas, and Matplotlib. Okay, okay. In the same way, inside the section, we have NumPy, Pandas, Matplotlib. So if you are beginning your machine learning journey, sorry, Python is a must. Without Python, you cannot enter into it. And then there is NumPy, Pandas, Matplotlib. They form the base. Okay, and then if you just go inside more detail, intricate. Okay, there are then what there are. Then there are other things like, there are machine learning things for such as, you know scikit scikit-learn. Okay, TensorFlow, flow, PyTorch. Okay, 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 these are the things. Okay, these are the things which are inside them. Okay, really sorry for this. Okay, but Python is must. It forms the foundation model. NumPy, Pandas, Matplotlib, they are also must. And then before moving into intricate details, you should know Python, then NumPy, Pandas, Matplotlib, and then whatever that is. But if you don't know NumPy, Pandas, Matplotlib, consider you are not even eligible to be, called yourself as a data scientist or machine learning engineer or whatever. So let's start with it. First of all, uh, this is, uh, first of all, we'll start with what is data. Introduction to data in Python. Okay, so basically, data is what is everywhere. Any MNC, or any startup needs data to function. Needs data to make decision, and machine learning is all about data. So okay, so data is everywhere in your phone's app usage, the temperature outside, or even the atoms on your shopping list. In this handbook, we will explore the four core Python libraries for working with data. First of all, this is the from SmartBridge, this material, so I would like to credit them. So first, we'll start with NumPy. What is NumPy? Okay, you can consider NumPy as, I'll just say, okay, NumPy is basically used for numerical computation. Okay, numerical computation. What do you mean by that? It is used to make arrays, multi-dimensional arrays, such as multi-dimensional arrays. Okay, okay, it is used to make arrays. It is used to make, you know, like, what you can say is you can just say np dot array. Okay, and you can just say 1 2 3 4. If I'm not wrong, then we will create an array of 1 2 3 4. Okay, so NumPy is basically used to make arrays. Okay, uh is used for as well as numerical computation. Okay, we will get, like, you can concatenate, you can do various operation on it. We'll go back to it, but basically keep one thing in mind, that NumPy is used for numerical computation. Okay, for now. Okay, then we have Pandas. Once we have defined the data, thing, Pandas is basically used for data manipulation. So NumPy is basically for numerical computation. You define the arrays, etc., or any data, or okay. Then Pandas is basically used for data manipulation, like, or changing the shape, removing null values, okay, changing column names, etc. Okay, so basically, let me read this one, changing column names, etc. Okay, then basically once you define the data, pandas is used for manipulating that data. Okay, so these are the two essential, and out of that, most of pandas is like highly used. Pandas is like it reads data from various files. Okay, various files such as CSV, etc. Okay, so it's must. Okay, and then we have mat matplotlib matplotlib and seaborn. Okay, these are visualization libraries. Okay, visualization libraries. Okay, visualization libraries, it helps to understand your data set better. Okay, and you can derive information from it using visualization. So let's start, I guess. Okay, now first of all, I'm not going to go with what is data. Basically, data is any information that is raw. Okay, okay, it can be collect, stored, processed, and analyzed. Okay, data is structured like tables, Excel, or databases, semi-structured like JSON or XML. Okay, HTML tags, or unstructured like free text, images, or audio. Okay, so these are the types of data. Okay, now again, this is numerical data. It contains integer or float. Categorical, basically strings. Okay, ordinal means it's like, it has follows a particular order such as low, medium, or you can just say secondary school, high school, graduation, post graduation, they follow particular order. So this is ordinal. Then there is a series data. So these are some of the types of data. Okay, which are using which are prominent in machine learning. Okay, then let's start with the NumPy. First of all, this is the command to install NumPy, pip install NumPy. I'll just do it. Okay, okay, uh, something wrong. Okay, okay, this is the command to install NumPy, and it's already installed in collaborator, so there's no need. If you are not using collab, you need to run this command. Then see, you can just see to import NumPy. First of all, you use to write import NumPy as np. Okay, import NumPy as np. Okay, this is you have now imported NumPy. Okay, then now as I told, array1 is equal to np dot array in bracket 1 2 3. Okay, and if I just say array1, I'll get the array 1 2 3. Okay, so I have used NumPy to create an array. So okay, then what is that? I can create a two-dimensional array as well. Okay, I can create then two-dimensional array as well. Okay, this is okay, and if I just say array 1 dot shape. Okay, I'm really done. If I just say array1 dot shape, it says that 1 rows and 3 column. Okay, it has 1 row, it has 3 column. Okay, and now if I just now if I want to define a two-dimensional array, I can just say, okay, 5 6 7. Okay, run this. Just a minute. And if I just say, now it's say two-dimensional, 2 rows and 3 columns. Okay, so you can use NumPy to define, create arrays, one-dimensional array, two-dimensional array. This is written everywhere. Okay, then these are some of the function like I use the function shape to calculate the shape of the array, the rows and column. I can calculate the data type the array contains. Like, if I just say, hey, what is the data type, and it will say me integer, because these are integer arrays. Okay, and if I just say something like, I can just say, let's change something. What the fuck I'm doing? Okay, yeah, and now if I just run this, you can just say it converted to float because I have entered a float number. Now some of these are the useful NumPy function. Now once you have created array, you can create an array of zeros. 2 by 3 means 2 rows 3 columns of zeros. 3 by 3 means 3 rows 3 columns of 1. You can create an identity matrix. Identity matrix basically means every diagonal has the element 1 and rest of everything has zeros. All the diagonal elements have ones. Then you can create an numpy.rn, like let's say it start from 0, it goes till 9, and at the interval of 2, so 0, and then 1 skip 2, then 3 skip 4, 5 skip 6. Okay, and if you increase to 3, then 2 will be skipped and 3 will be there. 4, 5 will be skipped, 6 will be there, 7, 8 will be skipped, 9 will be there. So start from 0 till 9 and end with a skip rate of 2. Okay, so that's what arrange means. Okay, then evenly spaced values, np dot linspace. Okay, what does it mean? From 0 to 1, from 0 to 1 we want 5 values, so evenly spaced, so 0, 0.25. So you can just say these values all lie between 0 and 1. Okay, it's all lie between, they all lie between 0 and 1. Okay, see this all right, and we have created 5 values. You can change this attribute to 6, 7. Okay, then we have array mat, and so we have defined an array, suppose 1 2 3, and if we just say add 1 to it, so each element will be added 1. Okay, plus 1 plus 1 plus 1. Okay, so 2 3 4, and if I just say array raised to 2, so 1 raised to 2 means what? 1 square. Okay, then 2 square, 3 square, 1 4 9. Okay, that's it, array dot map. So then we have reshaping the arrays. Okay, np dot arrange. Okay, what we have done is np dot arrange 12, and then we have created an array of 12 digits 0 to 11, and then we have reshaped it to have a shape of 3 by 4, 3 rows 4 columns. You can just use 3 rows 4 columns. Okay, simple. Okay, then np dot random. Okay, so basically what it does is it just gives us um random random values which are positive values, okay, um from anywhere. Okay, and it is the shape of 2 rows and 3 columns. Okay, so random dot random. Okay, random dot rand. Okay, then this is the same function now, random dot random. And okay, and 2 by 3. Now it can include negative values as well. Okay, and the shape is C, 2 by 3 column. Okay, the same. Now random dot rand int, this were we want only integer values now. Okay, so shape is 2 by 3, then it doesn't give like 0 point minus 0 point. Now it's giving you values like 1 2 3, not negative values. Okay, use first of all specify the range you want from 1 to 10. So okay, we have 1 to 10, between 1 to 10, and size is 2 rows and 3 columns. Okay, so this is the three function for generating a random number. The first one np random dot rand, and random dot random number, then okay, then random dot random integer. Okay, so this is it. So now we know that I already told you, numerical computation, you can create arrays such as multi-dimensional arrays and perform operations like concatenating, reshaping it. Okay, now once you have defined the data, now you once you created that, now pandas is for manipulating them. Let's go back now to pandas make data analysis in python easy, powerful, and flexible. It allows loading data from files, filtering rows, changing values, and aggregating result. Okay, now this is the command to install pandas. If you have not already installed it, you have to install it in the terminal of your either VS Code or a command prompt, and you need python install before for it. Or if you are using Colab, there is no need to do so. Okay, then you can create data structures in pandas. You can create data structure in pandas. You can either create one dimensional labeled array or two dimensional labeled array. So let's take an example of this. Okay, first of all, as we have imported numpy, you import numpy as np, you need to import pandas as you can give alias as whatever you want, but pd is considered a good alias. Alias just basically means uh, shortening the name, so we can use it without typing much of it. So suppose now if I created a variable name data, and now I have created a name dictionary with key, and these are the values. Okay, another dictionary count, these are the value, another dictionary city, and these are the value. And then I create df. Okay, df means data frame. We have created a variable data frame is equal to pd, it is pandas dot data frame, and we have passed the parameter data in it. Once we print, now you can see the arrangement. The name column is given here, and there is count column and city column, and all the values are listed like this. Okay, so we have created a data frame using panda, and we have passed the data here. Okay, so basically what we do is we create panda dot data frame. Okay, and we pass the data which you have defined. So in this way, these are like index 0 1 2, this is automatically assigned. Okay, in the same way, if you just say df dot head, what did it? Now we have created the data, right? This. Now if you write df.head, it prints first 5 rows. That's 0, 1, 2, 3, 4 is the 5 rows. Okay, so 0, 1, 2, 3, 4. Now if you give df.tail, it prints the last 2 rows. Okay, sorry, last 5 rows. 1, 2, 3, 4, 5. And inside this df.head, you can specify the parameter like 1, 2, 3 about how many top rows you want, or inside the df.tail you can print last 2 rows. If 2 is not given, it prints the last 5 rows. Okay, then we have df.info. It gives you info about columns in the data frame. Okay, suppose these are the column name. It contains 13 values, all are non-null, and the data type of it is integer, sorry, string, that is object. Then the first column count, it contains 13 null values, 13 value, and they are not null. Okay, you can see this is the values, they are integer. This is it contains one integer and two object, right? If I'm not wrong, one integer and two object. In the same way, df.describe help us to give statistic summary. There's a count, what is the mean, what is the standard deviation, what is minimum value, maximum value, 24% of it, 50% of it. Okay, then we can select a particular column like df names. We have only selected name, so it only gives us name. We can select name on count, it only gives name and count. Okay, then we have filter by condition. We just say df count greater than 50. Where count is greater than 50, we just say, okay, we specify the condition in one bracket that df count, we selected that column, and we specified a condition that it should be greater, and then we created another df outside the bracket, so it gives only such columns where df count is greater than 50. Okay, if you go back to where data set is defined at 50, more than 50, this is 200, 300, 100. So I guess 3. Okay, okay, there are 4. Okay, so this increase all count by 10. Df count is equal to df count plus 10. Okay, and now every count will be increased by 10. 200 will be 210, 300 with 310, 120 with 130. Okay, add new column. You can add new column. Df country is equal to India. Now you add a column name in country, okay, to it, and all the instances are of India. Earlier this column was not present. Okay, now renaming the column, you can rename the column. df.rename columns is equal to city, and you have rename that city to location. Now the city doesn't exist, it is now renamed to location, and in place is equal to true basically does the changes in the data frame itself. Oh no, it doesn't create a new instance or anything. Okay, now cleaning data. Now this is some of the cleaning data is basically what Pandas is used for, majorly. Pandas is used for majorly cleaning data. Okay. Now, what does cleaning mean? Now, there are some of the things. If you just consider this data set which you have defined using creating data frame from Pandas, you can see there are some not a number values. There are some none, which should not be in the data. So what do? We either drop them, we remove them, or we fill them. Okay. Now there are, if you want to remove rows with missing data, you just say df.drop na. Okay, and after dropping them, there are no null values, none value, etc. If you want to fill the null value, fill missing data with 0, you just say fill na with anything you want. So this was something you can do. Again, I'm not going to explain everything in detail, etc. This is the cheat sheet which I will provide in the description. Okay, now there are some of the function you can perform on them. Okay, reading and writing file. Okay, you can, now you can write to csv, you can read csv with the form pd dot read underscore csv and file name. Okay, you can read csv. This is the important thing. You will find this in every line in the machine learning. If you want to read from the csv file, you just say read csv. Okay, so I will give this cheat sheet in the description. You have to read this, perform on your yourself. I'm just browsing through it. Now we know, now we created the data using array, multidimensional arrays using Numpy. We cleaned them, manipulating them, perform operation of them pandas. Now once we have clean data, now we need to visualize them. Okay, how our data looks, how using charts, and that's useful for Matplotlib and seaborn. Now same Matplotlib is used to create static, animated, interactive visualization Python. This is the command to install it. Okay, and this is the line you need to use to import it. Okay, if you just, okay, let's take one example. We have imported the Matplotlib here, and then you have created x-axis, y-axis, and we need a plt.plot x, y. If you are writing a title and show, so this is how it look. 0, 1, 2, 3, 4, 5. This is the x value and y value is there. Okay. Okay. Y value is also there. Okay. Now you can see we have plotted it and we have given the title sine wave and then show. Show is used to show the data what you have plotted. Same goes for a bar chart. You have defined the categories, 3 categories, their values and their color. Now their categories, 3 categories: apple, oranges, bananas, their values, that is count, and their color, that is what is it? Red, orange, and yellow. Yeah. And then you given the title fruit, x label as fruit, y label as count, and then you have shown it. So basically matplot is used to use for visualization. Now this there is another library, that is seaborn. It is built on top of matplotlib. It is built on the top of matplotlib. Okay. And it gives you advanced visualizations, advanced visualization, like if seaborn has it, with the help of seaborn you can write minimal code and get a lot of done, right? You can get a lot of it. It has more details on visualization. Okay, so what I can say, this is if your matplotlib flip. Okay, this is matplotlib. Okay, and I'm really sorry. And then there is seaborn. Okay. Okay, so this from matplotlib we derived to. Okay, so what we did earlier, matplotlib seaborn has a base of matplotlib, but it is used for advanced graphs. Okay, advanced statistical graphs, etc. And matplotlib is also used basic graphs, but you need a lot of code to do things in matplotlib, while seaborn is a simplified version, etc. Okay. So this was all the overview. Okay, I'm not again, once again I'll provide this entire document in the description itself, but yeah, once again I'll revise what I wanted to say here is, first of all, I'll delete this one. What the fuck? Okay. Okay, delete this. Okay, I wanted to clear what I'm telling here you is. Okay, so Python is the foundation. Okay, then Numpy and built upon that Python. Foundation. Okay, build upon that Numpy Pandas Matplotlib. Build upon that Python foundation, and these are must. Without this, you are not going to go anywhere. Okay, if you take any project, there will be Pandas, Matplotlib use. Python is basically just, this is like a must. But when you need to know the libraries of Python, which you cannot skip, these three are there. So that's it, I guess, in this video.